One number dividing into another number evenly with the remainder of 0 is a very, very, very important concept in mathematics. And when you have an important concept like that, there's almost always approximately 1,000,000 different ways to say it. Every single one of these 6 things means the following thing. It means that when you divide 7 into 21, it goes in 3 times and the remainder is 0. It goes in evenly. In that case, we can say 7 is a factor of 21, or 21 is a multiple of 7, or 21 is divisible by 7, or 7 is a divisor of 21, or 7 divides 21 with symbols, or 7 divides 21 with words. You might think, well, okay, that's pretty easy, who really cares? But notice, if you turn one of these things around, it's not going to be true. So it is not true that 7 is divisible by 21. You got to be careful. Divisions can't be turned around. So every one of these phrases has a correct order and an incorrect order, and that is a little bit tricky. Notice also that there are some facts that are true. If 5 divides a number, does 10, which is a multiple of 5, have to also divide the number? And the answer is no. Here's an example. 15. 5 divides 15. 5 divides into 15 without a remainder, but 10 does not. So this is not true. But if you reverse it, if 10 divides a number, does 5 have to? Well, the answer is yeah, that's true. For instance, here's a number. 10 divides that number, but 5 also has to divide that number, and the reason why is 5 divides 10. So 5 is going to divide 30 for sure, since 10 divides 30. So we have to be a little bit careful here. There's something to think about. Prime factorization is another very important aspect in mathematics. In fact, in arithmetic, prime factorization is probably the single most important thing. So how do we do prime factorization when a number's kind of hard and we don't want to use a calculator, although you can use calculators in this class? Well, we want to look for something that divides 513. And we know that 5 plus 1 plus 3 is 9. And 9 divides 9, so 9 has to divide 513. So this will be 9 times something. And the way to find out what kind of something is to go ahead and do this work. So we're getting 57. So 9 times 57. Now, 3 goes into 57 and 3 goes into 9. So the 9 is 3 times 3. And the 57 is 3 times whatever you get when you do this division. Of course, you could be doing this on the calculator. It would not be wrong. But I was born before calculators, so I tend to not use one unless I really feel the urge. So I have 3 times 3 times 3 times 19, or 3 to the third times 19, or 3 to the third times 19 to the first. I don't really care which one of these you use, but for now, for an answer, this one seems to be pretty good. That's the prime factorization of 513, and it's not all that bad because 3's went into it, and 3 is a pretty small number. Here we're asked to find the greatest common divisor and the least common multiple of these two numbers, 32 and 224. Notice if we were dealing with the denominators of a fraction, this greatest common denominator and least common multiple might possibly have different names. The least common multiple is sometimes referred to as the least common denominator. Sometimes instead of a greatest common divisor, we talk about a greatest common factor. These are basically exactly the same thing. These are close to exactly the same thing. It's just that we talk about denominators when we're dealing with fractions. And in this problem, we don't have any fractions. So what we're going to do is use kind of one of the methods suggested in the book, although there might be other methods that are just as good that we'll see in V4, video 4. So you can look at that if you want some other information. So we're going to do the prime factorization of 32. 32 is 4 times 8. 4 is 2 times 2. 8 is 3 2's multiplied together. So this is 2 to the 5th power. Now, 224 is kind of weird, kind of different. I think it's 7 times something. I think 7 goes into there just because I do, although I don't know where the 3 came from. Man, it must be the pen. I don't quite know what happened there. Maybe it's that 7 goes into 22 3 times. That's probably actually it. 7 goes into 14 twice. Of course, you could be using a calculator to do this. And we already know what 32 is. It's 2 to the 5th. And so we have 32 here, and we have 224 here. And now we want the least common multiple and the least common denominator. Let's build the least common multiple first. If we take a look at all the different kinds of prime bases, 2's and 7's, we want whichever one has the most. So this one has 5 2's, this one has 5 2's. The most that anyone has is 5 of them. This one has no 7's, this one has 1 7. The most any of them have is 1 7. So that product, the product of the mosts, that is the least common multiple. And notice we don't have to have a calculator to multiply it out. We already know that that's 224. So 224 is the least common multiple of 32 and 224. That's kind of weird. To find the greatest common factor of these two numbers, we do a similar thing, but we kind of choose whichever one has the least. So this was the least common multiple. Now the greatest common divisor, or the greatest common factor, we still look at 2's and 7's, but we pick whichever one has the smallest amount of 2's. It's tied, so that's 5 of them. Which one has the smallest amount of 7's? It's this one, and that's none of them. So the greatest common divisor is 2 to the 5th, and we already know that is 32. Now notice, it is not always true that if you're finding the greatest common divisor of two numbers and the least common multiple, that you get the two numbers themselves. That's a little bit of a coincidence. It does happen sometimes, but it often doesn't happen. But this plan that I've shown you always works. So let's do it again. Let's find the greatest common divisor and the least common multiple of two other numbers. This is 2 times 39. 2 is prime. 39 is 3 times 13. So we got a prime factorization of 78. 104, I don't really know. It's 2 times 52. And that's 2 times, and then 52 is 2 times 26. And 26 is 2 times 13. So I think I've got the prime factorization there. And there. Now let's build the least common multiple. We go through the primes, bases 2, 3, and 13, and we pick whichever one has the most. For 2's, this one has the most. 104 has the most, and it's 3 of them. For 3's, 78 has the most. It's 1 of them. For 13's, they each have a tie, so it's 1 of them. So this is the least common multiple. The least common multiple is usually the biggest of these two. And we do actually need to calculate it. So it's going to be 8 times 3, which is 24, times 13. Another way of doing that would be to recognize that it's this number times 3. So it's this number times 3, which would be 312. The greatest common divisor we go through the 2s and the 3s and the 13s, but we pick the one that has the smallest. The one that has the smallest number of 2s is this one. The one that has the smallest number of 3s is this one, and that's not anything. And the one that has the smallest number of 13s is either one of them, and it's tied. And so this is the greatest common divisor. Now, there are some other facts here that you need to know. One fact is that if you multiply two numbers like these together, you will always get the same thing as if you multiply their greatest common divisor and least common multiple together. And you can see on this particular problem that happened, and we can use that to help kind of check our work sometimes. We can even use it to help us do calculations. More on some of those calculations later in V4. However, in problems 73 through 78 in section 5.1, they show you another way to find the greatest common divisor, the greatest common factor. And it's kind of an interesting thing. Euclid is the first one to be recognized to doing this. But if you want to find the greatest common divisor of 78 and 104, you can create a series of divisions. You divide the smaller into the bigger, goes in once, and then you take the remainder and you divide it into the divisor. And you do it again. Whoops. And you keep doing this until the remainder's 0. And when the remainder's 0, you go right up here to the divisor, and that's the greatest common factor. Sometimes you get it right away, like in the second division. Sometimes it takes 5 or 6 or 7 divisions. Not usually, but sometimes. But this is a pretty fast way of finding the 26. And so that's what they're asking you to do. In problem 73 through 78, they're asking you to do these divisions, and they show you some more examples, but I thought I would show you an example. If you need more information about these least common multiples and greatest common divisors and these different methods, you might want to look at video 4, which extends this just a little bit.